بسم الله الرحمن الرحيم والصلاة والسلام على أشرف النبيين سيدنا محمد وعلى آله وصحبه أجمعين. Today, dear students of third prep, we are going to revise the first unit and the first lesson in the first unit, which is come to see chemical reaction. This unit is about chemical reaction and how chemical reaction happens and the speed of chemical reactions. Today we are going to revise lesson 1, which is chemical reaction. Come with us to see what we are going to talk about. In this section of lesson 1, we are going to say that the atom is the smallest unit of the element, as we know for sure. The atom is the smallest unit of the element, undergoes chemical reactions. This means the chemical reaction happens through the atom. The atom consists of, as we see here, proton, positive proton, and neutral neutrons inside the nucleus. So inside the nucleus we have two types of particles, which are protons, positive, and neutral neutrons. Outside the nucleus there are 7 energy levels which contain negative electrons. So the atom consists of, the nucleus contains positive charge positive charge protons and the neutral charge neutrons. Electrons are negatively charged particles which revolve around the nucleus in something called energy levels with high speed. We have two definitions related with the atom, which are atomic number and the mass number. If we have any symbol of any atom, bottom of this symbol is the atomic number, and at the top of this symbol we found the mass number. The atomic number here, we said it is number of positive proton or negative electrons. If we take an empty page like this here, this is the symbol of any atom. Here is the atomic number, and here is the mass number. As we said, the atomic number equal to positive proton or negative electrons, and the mass number is the sum of protons and neutrons. If we talk about sodium 1123, so this atomic number refers to positive protons or negative electrons. So this atom contains, I hear you are right, 11 positive protons and 11 negative electrons. And mass number 23 is the sum of protons and the neutrons. So the summation of protons and the neutrons is 23. So what about the number of neutrons? Number of neutrons equal mass number minus atomic number. For sodium, it will be 23 minus 11. It will be 12 neutrons. Let's take another example. If we said we have Mg1224, find the number of protons, number of neutrons, and the number of electrons. The number of protons and electrons is easy because it is the atomic number, so it has 12 positive protons and 12 negative electrons. The number of neutrons is the mass number minus atomic number, 24 minus 12 equal 12 neutrons. Back to the revision. Here, atomic number is the number of protons in the nucleus, or protons or electrons, as we said. The mass number is the number of protons and the neutrons, summation of protons and neutrons. Electrons revolve around the nucleus in fixed orbitals. We said each atom contains 7 energy levels. These energy levels is different in energy. The least energy one is K, and the highest energy is Q. Let's continue, dear students. As we said, There are 7 energy levels. The least energy is K and the highest energy is Q. So each energy level here, this is the nucleus, contains and contains 7 energy levels. K, L, M, N, O, P, Q. The lowest energy level is K and the highest one is Q. The electrons revolve around the nucleus in these energy levels in the relation to n squared. So we replace n with the number of energy level 1 K, 2 L, 3 for M, 4 for N, 5 for O, 6 for P, and finally 7 for Q. This relation is applied for the atom until the fourth energy level, because the atom becomes unstable after the fourth energy level. So here, the first energy level K is saturated by 2 electrons or filled by 2 electrons. Here, the second one is filled with 8 and the third one is 18. And finally, the fourth energy level is filled with 23 electrons. From level 5 to 7 are filled by 23 electrons. And this relation doesn't apply because the atom, as we said, become unstable. Because the level can only contain 23 electrons, this presence of more 23 electrons in the energy level would make the atom unstable. So, as we said, the relation doesn't apply after the fourth energy level because the atom will be unstable. Valency is the number of electrons gained or lost or shared by the atom in the chemical reaction. Come to see what about the valency. It is easy to understand about the valency. When you talk about valency, we talk about the atomic number because the reactions or chemical reactions happens by the outermost energy level electron, this one. Imagine we have a shawarma sandwich. It costs 8 pounds. You have 1 pound of the cost of this shawarma. I know most of you like shawarma. Most of you like shawarma. It costs 8 pounds. You have 1 pound only. So it's the easiest way is to withdraw this one, get rid of this pound, or withdraw 7 electron. يعني تصرف الجنيه ده ولا تستلف 7 جنيه. طبعا كل الفاهمين هيقولوا we are going to get rid of this one. So here we have 11 protons. We have inside the nucleus 11 protons here, 11 protons, and outside we have 2, 8, 1, 11 electrons. When we get rid of this one, the atom becomes 2, 8. So the number of proton is more than the number of electrons. So the atom has to become ion, but positive ion. So this atom lost 1 electron. So its valency is monovalent. Again, to another example, if we have Mg1224, we deal here with the atomic number. Distribute the atomic number to 8, 2. If you have 2 pounds, just 2 pounds from the shawarma, which was cost 8 pounds, you will get rid of these 2 electrons. So the electronic configuration will be 2, 8. Here with 12 protons and 10 negative electrons, as we said here in sodium. It become negative ion and the valency become, yes, divalent because it lost 2 electrons. If we take, for example, S16, here 2, 8, 6. In this example, you have 6 pounds. So you will get rid of this 6 pound or, yes, borrow 2 electrons. They still have 2 electrons. So the ion will be 2, 8, 8. Here 16 positive and here 18 negative. Right. So it form negative ion, negative 2 because it borrow still have 2 electrons. So it will be divalent. And this is the idea of valency. Come to see here, sodium, valence mono because it lost 1 electron, calcium lost 2 electron, aluminum lost 3 electron. They are mono di trivalent. But when the atom lost electron, it becomes positive ion as we see here. For sulfur and chlorine, here and here, it gains electrons, so it forms negative ion, and the valency is mono and di. For silicon, it shares by 4 electrons, so its valency is tetravalent. For neon, its outermost energy level 2, 8. It doesn't lose or gain or share, so its valency is 0. To the ion, here the idea of the ion is obvious now. When the atom lost electron, it forms, yes, I hear you, positive ion. When the atom gains electron, yes, it forms negative ion. As we see here, all the elements like sodium, potassium, calcium, magnesium, barium, they are lost electrons, so it forms negative ion. All the atom lost electron, it forms a positive ion. While the atom gains electron like fluorine, like chlorine, like bromine, they are negative oxygen, sulfur, they are negative. Why? Because it gains electron. Here we must take care about this, the atomic group. What is meant by atomic group? It is a group of atoms are bounded together and go into chemical reaction as one atom. When they enter the chemical reaction, they enter as one atom. As what? Hydroxide. You have to keep this in mind. The symbol of the hydroxide, nitrate and nitrite, bicarbonate and carbonate, ammonium and sulfate. Here the valency of these atomic groups are 1, while the valency of carbonates and sulfate is 2. The phosphate group valency is 3. Write chemical formula. Come to see how to write chemical formula. There are 3 steps. The first, the symbol of the metal. We have to know the symbol of the metal and the non-metal, or the symbols of the chemical formula. Here, the symbol of metal and the symbol of non-metal. The second mostly important thing is to know the valency of the element, and we know how to get the valency, the number of atoms gained or shared or lost. And the atomic group, we have to save in mind the valency of the atomic group like carbonate or sulfate or phosphate or hydroxide, anything is this. How to write the symbol of, come to take an empty page like this. How to write sodium chloride. Number 1, the symbol. Sodium symbol is Na, chlorine is Cl. Number 2, the valency. Here, sodium 11, 2, 8, 1. So it lost 1. Here's valency is 1. Chlorine is 17, 2, 8, 7. It gains 1. so its valency is 1. There is no difference in valency, so NaCl is the formula. Now write the sodium sulfate. Here sodium, we wrote it 1 valency, Na sodium, it's simple. Sulfate SO4, its atomic group. Sodium, we said its valency equal 1, and sulfate its valency equal 2. Here we have to go to the third step. Cross here, sodium takes 2 and sulfate takes 1, so the formula Na2SO4. Another example, write copper hydroxide. Copper Cu hydroxide OH. The valency of copper is 2 and the valency of atomic group OH is 1. Cross 1, 2. So the sample will be CuOH2. So there are 3 sample steps. 1. The valency of metal and metal, or the 2 radical of the formula. The valency of the elements that share in the compound. And the second or the third is the cross between the 2 atoms, or 2 components of the compound actually. Now we are going to the new section, is chemical reaction. Chemical reaction involves breaking bonds on the molecule of reactants and forming new bonds. We have to define it by more simple way. Here, add a new page here. If we set A2 plus B2, it forms 2AB. This is called the molecular formula. If we write it as structure formula, it will be A bond B, A bond A, B bond B, here 2A bond B. This before the arrow called reactants. And after the arrow called products. So simply, chemical reaction is breaking bond in reactants to form a new bond in products. Simply add this, breaking bonds in what? In reactants to form new bonds in what? In products. And this is the definition, or the simple way to define chemical reaction. Example of chemical reaction, Mg plus O2, it gives 2 Mg. This is, as we said, reactants, and this is products. Sugar plus O2 gives CO2 plus H2 plus energy. Again, here these reactants and products. In green plants, the reaction between carbon dioxide and water produces food of the plant. This process called photosynthesis process. Here, in the car engine, and gasoline burns with oxygen, producing heat energy, carbon dioxide, and water vapor. Here, this is the reactants, and here, this is the products. Chemical industry uses various chemical reaction to produce new substances, such as fertilizers, medicines, and artificial fibers, as we wear nowadays. Chemical equation, you saw this one, as we write here, it's chemical equation. It is symbols that represent reactants and the products and the conditions of the reaction as it is present. لو في condition, we have to write it here above the arrow. Here, the chemical equation expresses the chemical reaction, reactant and the product. The simple way to define the chemical equation, it is the symbol that represents, reactants and the products and the condition of the reaction if it is exist. Now to the most important part, which is types of the reaction. The first one, dear students, is thermal decomposition reaction. In the thermal decomposition reaction, there is one compound, it will be two after decomposition. Here, as we see, mercuric oxide, by heat, it will be, yes, mercury and oxygen. We called it one compound become two, we called it thermal decomposition according to the presence of this triangle. This triangle means heat. Yes. Some of metal hydroxide, like copper hydroxide, it also decomposes to copper oxide and water. Also again, one compound, it gives two. We called it, yes, thermal decomposition. Here, copper carbonate, it gives copper oxide and copper dioxide. Copper sulfate, it gives copper oxide and sulfur trioxide. All of them, again, number NaNO3 sodium nitrate, it gives sodium nitrite and oxygen. This type of reaction, one compound gives two compounds by heat, so we called it, yes, thermal decomposition. Now to the substitution reaction. The substitution reaction is simple substitution and double substitution. With the simple substitution, metal replace metal. It depends on the chemical, it depends on the chemical reactivity series. It is the arrangement of, again, it is the arrangement of metals according to its activity. The active elements here, active metal replaces the less active one. Chemical reactivity series, here the active metal replaces the less active one. So as we see here, magnesium is more active than copper. So it will replace copper here and replace its position to give magnesium sulfate. We called it simple substitution. Here also, Zn is more active than hydrogen, it will replace it. Here, but copper is less active than hydrogen, so it gives no reaction. This is the chemical reactivity series. It is the arrangement of elements according to reactivity. The most active one is lithium. The less active one here is hydrogen. After the hydrogen one can't replace hydrogen. What about the double substitution? Here, all of them simple substitution. Here, the double substitution, the one we concern here. Here, substitution, the metal with the metal. Here, Na replace hydrogen and the hydrogen replace Na. So it gives, instead of HCl, it will be NaCl and HOH would be water. Na will replace hydrogen here and the hydrogen replace Na here. It gives NaCl plus, yes, H2CO3. This is weak acid. This one is weak acid. It gives CO2 by H2O. Here also NaCl plus AgNO3 double substitution. So it's two compounds gives two compounds. This is double substitution. Double substitution. Each metal replaces each other. Now to the oxidation reduction process. Simply, oxidation from its name, oxidation, it is the reaction which increases the oxygen content. Reduction clearly decrease the oxygen content in the product or in the substance. Here, CuO plus H2O. CO here rich in oxygen and here poor in oxygen. So it lost oxygen. A reduction is happening. Oxidation, here is no oxygen, here is oxygen. So it is oxidation. So oxidation, the reaction with oxygen content increases, and reduction, reaction with oxygen or hydrogen content increases or oxygen decreases. So here we have two definitions for reduction. If the hydrogen increases or the oxygen decreases, we call it reduction. Oxidizing agent, it is the substance that give oxygen or gain hydrogen. So when it gives oxygen, what process happen? Yes, reduction is happening. So this substance which reduction happened to it called oxidizing agent. Reduction agent, the opposite one, the substance gain oxygen or hydrogen in a chemical reaction. So when the reducing agent, when the here substance oxidation happen, so it is reduction or reducing agent. When the oxidation happen, it is reducing agent. But where the substance reduction happens, it is oxidizing agent. So it's simple to understand what is the difference between oxidation and oxidizing agent. Oxidation, the substance itself gain oxygen. The oxygen become rich in oxygen. So itself is a reducing agent because it takes oxygen from other substance. When this substance a reduction happens, means it becomes poor in oxygen and rich in hydrogen. So it is, yes, oxidizing agent. It helps another substance to oxidize. This is what's called reduction oxidizing agent. Another term is to understand oxidation and reduction. So the first term, we have to conclude that oxidation, it is a process that makes the substance rich in oxygen and poor in hydrogen. That's reduction. It is the process that makes the substance rich in hydrogen and poor in oxygen. The substance which oxidation process happen to it, yes, it becomes reducing agent because it helps another substance to reduce. The substance which reduction happens to it becomes, yes, oxidizing agent. This is the conclusion of the past or formal definition of oxidation and reduction. This is here a new explanation of oxidation and reduction. Oxidation, as we see here, is the loss of electron, and reduction is gain of electron. So when the atom loses electron, such as sodium loses electron, so oxidation takes place. When the chlorine gains electron, so reduction takes place. When the oxidation takes place, this substance is called, yes, reducing factor. When the reduction takes place, this substance called, yes, oxidizing factors. So loss of electron called oxidation. The substance which gain electrons, yes, is called oxidizing agent. It helps another substance to oxidize. Oxidizing agent is reduced in the reaction, and the reducing agent is oxidized in the reaction, as we said. Now try to solve. I will send anyone that will send me for Ahmed Diab 2807 at gmail.com. I will send this PDF for him, and I will let you solve this homework until we meet again. Thank you and goodbye.